Welcome everyone to Robot Builders Night Virtual for October 21, 2025. And usual agenda here, DPRG news. We have one person in the queue, Mike, and then we'll go to the open mic section. So DPRG news, and let me ask first, is there anyone here who wants to jump in owing to a time constraint, you have homework to do, or and want to say something or ask something as a priority? Like, nope. Okay. So DPRG news. So we've got the monthly meeting this Saturday, the October 25th, and we'll have a two-part double-header presentation. Part one will be part two of my Git and GitHub talk. The second part will be we'll have a gentleman from HBRC who has made a really amazing video of an interview, an AI-generated video of somewhat famous, apparently, interview by a New York Times reporter with an early Bing AI, in which the Bing AI really went off the rails. So that's going to be Thomas Messerschmidt is going to be presenting that. So I've seen the presentation before. It's really a powerful presentation. Very emotional, and gives you a sense of the power of AIs to pull people along with them. So that's the meeting. 10 o'clock. It'll be on. It'll be live, and it'll be in person as well as virtual. The same meeting URL that you used for joining this meeting will be used for that, and the details are on the website starting at 10 o'clock. Well, 10:15. We always start at 10:15 on Saturday. Next thing, YouTube. I want to just throw this out. Feel free to volunteer here or send me an email. But I'm going to be out for 6 weeks, beginning at the start of November, and I would really welcome someone who is able to take over the handling the recordings and posting them, editing the update, the summary, and posting the recording on YouTube. I can walk anyone through that who's able to help in that way. So an invitation, a request for anyone who can do that. Any news from UTA, especially as far as maybe any relationship with DPRG or anything like that?
Hello. I mean, I've reached out to them, but I think it's just the professor is just not really wanting to move forward with it. I'm trying to push for it. So I'll let you know.
Okay, cool.
Yeah.
All right. With that, let's move on to Mike. Is in the queue. You got like new developments. You just always have something new going on, Mike.
Way too slow. For some reason, I'm just not as good as I thought I used to be at solving problems. I work hard and get stuff done slowly. So So I've been trying to get my sensors working and get them integrated into the robot localization, which is like the EFK modules, the nodes, and I tried to just do it all at once, and it completely failed. So I've been trying to go through it slowly. So what I've done is I've gotten my IMU. Basically, I'm trying to get my IMU working as good as I can, and I'm having some issues with the compass, the yaw, I guess, and so I was using I'm using a BNO 085, which is supposed to be a relatively good IMU with a pretty good compass, and it seems to work pretty good. But I had to switch. I had it on a mode that wasn't working well, so I created it has a lot of operating modes that a lot of messages you can get out of the compass, out of the IMU, and one of the things was a rotation vector, and I think I was selecting the wrong rotation vector because it just wasn't working well and would never calibrate. And so I tried a couple other rotation vector types, and I ended up with the straightforward rotation vector in the BNO 85. But it needs to be calibrated every time you turn it on. So, and it'll lose its calibration when it's idling for too long. But on this course, it's not going to be idling. It's always going to be moving. As long as it moves, it seems like it keeps at least its calibration status. So I was going to do a little show and tell in my room here.
Are you just using yaw?
Pardon?
Are you just using yaw? You know.
Okay, I'm just using yaw out of the IMU, and I also fused in the acceleration. It seemed to do a pretty good job. Trying to get the parameters, the params file work for the localization for the EFK node to work. I had to go study it and made some tweaks and found out some of the mistakes I had, and now it works. So I'm using the yaw from the compass and the acceleration because it doesn't seem to hurt anything, and it's supposed to be as much data as you can. I'm using the velocity in the X direction from my shaft encoders because those work good. But my steering, I can't use my steering from my wheels because it just has really bad. I don't have a feedback mechanism, and I realized that even if I knew what position my servo was in, the linkage and stuff has a lot of play, and the tires have a lot of play. Like when I go forward and reverse, the tires change a little bit, and it changes the direction that it's trying to move, that it moves. Like when I go in reverse, it'll in a circle, it does a tighter circle. If I go in the forward direction with the same wheel or servo angle, it has a larger range. And so it's like, I can't use the steering. So I'm just using the IMU's yaw to understand how it's rotating.
And
so that's my plan. Huh?
Is the yaw that you're using the rotational velocity, or are you getting the actual angle out of the IMU?
Actual angle, yeah.
Actual
so basically,
heading.
It gives you a quaternion. Am I saying that
Yep.
right?
Yep.
And so I'm using that, and so I had to adjust it to meet the standards of Ross, which is instead of north being 0, east is 0. So I had to add 90 degrees or half a pi to it.
Yeah.
And that seemed to work pretty good.
And when you said it wasn't working well, what were the symptoms that you saw?
Which time?
Well, you said that you were having trouble with the IMU and struggling to get it working right. I'm just wondering because I've seen some odd problems. I'm just wondering if you saw.
So the IMU, like the BNO85 has a lot of different modes. I can't spit them off the top of my head right now, but things like a rotation vector for a game rotation vector versus just a plain rotation vector, or a stabilized rotation vector. Oh, that was my robot telling me what the battery level is, if you heard that. And I think the straightforward plane rotation vector is what I'm trying to use right now, and it actually seems to calibrate, which is really interesting. The game rotation vector doesn't have any absolute coordinates to it. And it comes up fully calibrated because there's nothing to calibrate. So the BNO85 has a calibration status of 0 to 3, where 0 is junk and 3 is reliable. And in the stabilized rotation vector, I could never get the calibration status to be non-zero. I mean, I would try to calibrate. I'd pick it up, I'd wiggle it, I would drive it around, and the status would always be 0. But when I switched to the rotation vector mode of the BNO85, it calibrates. It gives me a status of 3. Sometimes it's not perfect, but if you start moving, it starts to have a good value. So you can see my robot right there on the floor here, and I'm going to control it with my controller here to get it to move, and I'm going to put Foxglove on the screen. I have a lot of different debug screens. So on the Foxglove, this is the battery. This is the calibration of the IMU, and it's in calibration 1. So it's 0, 1, 2, 3. This is my compass heading, and this is supposed to be east right here, but it's pointing straight up with 0. And this is my GPS satellites in view. So those are the gauges I put on here. And this is my my plot for my Odometry angular Z. And I put 3 plots on here. One is, not sure why it's just jumping around. One is the wheel odometry twist, basically what I was calculating it based on the steering angle. And the other one is the IMU's angular velocity. And then I put another one on there, which is the angular velocity coming out of the local EFK filter, which is supposed to fuse the IMU with the wheel stuff. I'm not using the wheel's angular Z because it's not reliable or trustworthy. And I'm trying to get the IMU's angular Z to be trustworthy. And this screen here is the linear velocity. And it has the odometry, it has the wheel odometry, twist linear X, and it has the odometry on the output of the EFK filters linear X. This screen here has my compass data, my basically the so basically there's a compass AZI data, which is the azimuth data. It's the same as the AZI data on this gauge here. And then it has the IMU's orientation C and W, and the Odometry output of EFK filter orientation. And so I wanted to make sure that they were tracking and that was messing it up, and I had some issues in my configuration of the EFK filter that caused it to act really bizarre. And I found those by trial and error, basically, and removed them. So now I am going to try to get this thing from out. Now to move it. So if I move it backwards, you can see in this field here, I have the it gives me some negative velocity, and the angular velocity is pretty much just noise plus minus. It's just wiggling around the platform, and when I go forward, I have to run through the window. I have the positive velocity, and if I have it, if I try to put it in a circle, so I just sort of calibration with this case, I can hear it's enunciated, and so you can see on this plot here that I'm going in a clockwise direction. So I'm thinking of a calibration routine. I think it's do the make the robot do. Can you see my robot on the screen?
Can we see your robot on screen? Yes.
Yeah.
Okay. Yeah.
Your audio is real difficult
Garbled.
to follow, Mike. It's like
Oh.
sort of like
Can barely
distorted
understand you.
and-
Oh. Wonder why. So what am I doing here?
It's very choppy. Are you using?
Where's my Foxglove? So I wish I had a good microphone. The robot makes a lot of background noise. Can you hear me now pretty well?
Yeah.
Okay. So
Yeah.
Okay, so I'm going to when I look at my robot, I'm not speaking at the computer, and that's what the problem is. I'm gonna do my dance that I've come up with, and I got to figure out how to program the. So I was basically going to find a way to start it with a button on my remote. This is what I want to do, and I'm sure it's going to be done, and it'll start the dance, and it'll stop it when the calibration reaches 3. So I don't have it now, but this is what I want to do. So I'm going to make it. I'm going to do the dance that I'm thinking of. Stop it. I'm doing a very good job. But basically, I was thinking of making it dance around like that. And I was thinking I'd also use that like when I get in the cone vicinity, I would have little, so I can see what's going on. Move the camera more. So I think I can use the same data for both calibration and cone search when I get into a vicinity. So the one thing I did notice that has me a little unknown here is you see that I'm changing the odometry screen here, the angular D. So what I'm noticing is like these blue dots. I'm going to turn the light on the blue dots. Okay, so the blue dots is the wheel, is the steering odometry, and the red line is perfect aligned with the other line, which is the IMU's angular Z and the K filter's angular Z. And of course, since I'm only using the angular Z from the IMU, it should be aligned. So that's what I'm checking. But what I'm noticing is there's like a half a second delay. You can see that there's just a shift, a delay in from the wheel odometry and the IMU. So I'm a little confused about why the IMU would have such a delay. Like I would assume that the wheel odometry, which is the steering, is probably instantaneous, so that's as fast as I can plot it. And then somehow there's a delay both from the IMU, and the EFK filter isn't adding any delay, and it's about a half a second. Has anybody seen that before? Like you can see it here where it goes up real clearly.
Yeah. Oops. Yeah, no, I thought you could run the BNOs at like 100 hertz rate. So
yeah, it's running at 30. I think it's running at 30 hertz. Yeah.
Yeah. So I wouldn't think it would be half a second delayed.
You can see all the dots on there. So it's running with a lot of samples per second. So I don't know why it's a half a second, or it's actually a little more than a half a second.
Mm.
Are you averaging a bunch? I mean, could it be a lag from an averaging algorithm?
That's what I was wondering. Averaging or filtering of some sort?
There's inside the EFK filter, there's an averaging function, but I have to go look at my parameters for my IMU. I didn't think I had averaging, but maybe I do. So maybe I need to look into that and reduce that averaging and just get a noisier signal.
Where is the wheel odometry twist derived from? What sensor?
Well,
An encoder?
the wheel odometry twist is just the signal I'm sending the servo, basically.
Okay.
And then it gets computed into velocity using the because I know the wheel spacing and the forward velocity. And so if you know the wheel spacing, forward velocity, and the angle of your wheels, you can compute the steering angular velocity.
Okay, so then it seems like it's correct that the steering would precede the actual angular velocity, because you turn the steering wheel and then you start driving maybe half a second later, or even if you turn the steering wheel, the effect isn't going to be of rotation isn't necessarily going to be totally immediate, right?
Not instantaneous, yeah. That would make sense.
Yeah, because I'm going to walk over to the robot here, and it has a really, the suspension is real, it has a lot of suspension. So I was wondering I was wondering something like that. I wasn't thinking it'd be a half a second delay. I was thinking maybe 100 milliseconds from when I move the motor and then engage and starts it to move, and then the body starts following. So I was wondering if that is a delay. Yeah.
Is the left-hand plot, is the top left plot the velocity? The linear velocity?
Which one?
Top
Oh, this
left?
one? This
Yeah.
one here?
Yeah.
Yeah. Uh-huh. And so basically on the graphs here, you can see that really fine line moving.
Yeah.
And so you can see when my velocity is changing, my linear velocity, then the velocity here changes because the lines will match up in the plot, so you can see how all the plots are doing relative to each other at a particular time.
Mm-hmm.
So that's one of my things is like, I don't think it's going to kill me to have that half-second delay, but I want to understand it. And if I can understand it, maybe I can reduce it.
So what we're looking at here is where it was that like big lump in the linear velocity is where it was moving forwards, and the
Hold on 1 second. I want to answer this call and get back. Hello, it's Mike. I'm on a phone call. Okay, bye. Sorry about that.
Can you go back, take the cursor back to the beginning of forward motion in that big lump and see where it lands on the rotation, the twist?
So I got it here, and it's lining up right here.
Okay.
This one.
Okay.
So
So you began at the same time as you began motion, as it began moving forwards, the wheel, the servo was commanded to turn, and the command to the servo will lag a little bit behind the actual wheel position because it takes the servo a little bit of time to react.
Yeah, you can see that moment when I am the job went up went down.
You're all broken up, Mike. We can't understand you.
So on the angular motion, the motion started on the forward velocity. You can see that I had a motion in the opposite direction when I was eventually. It is because that's the cause of my game. But yeah, yes. See that at this point here, everything started on the angular velocity at the same time that.
Well, Mike, you're just unintelligible.
Yeah, can't understand a
Oh.
word you're saying, Mike. Sorry.
Yeah, sorry.
Sorry.
An interesting thing is the way the IMU actually reports an opposite rotation from the wheels, beginning right there where the cursor is, and then it like goes back down to zero. It's almost like maybe the twist, like the roll in the body is causing it to seem to rotate in the opposite direction before it actually starts moving.
Yeah, that could have been my just not doing a good job with the knob. Let me be a little more careful and run a little test. So I'm going to start. So I'm going to run a test again where I'm going to make sure that the steering is set before I do the forward motion. So I'm going to do a forward motion. Okay, so I did a forward and reverse motion, and then I'm going to look at what happened here. And
Somehow your Foxglove got unshared.
huh?
We're not seeing the
Unshared.
Foxglove stuff.
Oh wow.
It's gone. Is there on the controller? Is there? Do you have to go to like a zero velocity command, like going forward to backwards or backwards to forward? You have to actually stop to get it to go forward or backwards from being in the other of the two. I wondered if that could be.
Here. I just go up and down. Up or forward, down or reverse.
Yeah, still can't understand you, Mike.
Oh, I go up for forward, down for reverse. Can you understand what I just talked about?
Well,
Hello?
I think
Yeah.
Mickey Dean might be onto something that when he presents his screen, his sound goes wonky.
Oh. Okay.
I think it's given it all it's got, but it's not enough.
Okay. So
Not enough bandwidth.
yeah. Okay.
Ooh.
So,
How about a cell phone connection for the voice? And can you use your cell phone to do
Yeah.
the voice part? Maybe.
done it before. Let me see.
Something's swiping your voice packets.
Okay, so let me find. Okay. I'm gonna turn up my microphone here.
Are you
Hey.
saying something?
Mike, maybe you could turn your video off on your feed, and that might help with the bandwidth issue.
Here we go.
Okay, so
Turn your camera off.
now I'm using my phone. Does it sound better?
Yeah.
So does it sound better now?
Yeah.
Yeah.
Okay. So so what am I doing? Okay, so this is the beginning. So I put the cursor on the forward velocity where it started, and you can see the cursor over here where
We're not seeing
Nothing's
the
happening
cursor.
on your screen.
There it is.
oh,
Oh, there you go.
I think there's significant lag happening. The cursor just popped up, so I think your Wi-Fi is struggling, or your home internet is struggling. But we got.
Yeah, I can see lag in his video there on the camera.
Yeah.
I'm taking my phone off. Took my
Yeah.
phone off the Wi-Fi just in case.
You know what? If it's a half-second lag, that might explain his graph.
Yeah, so, huh. My phone has a bad connection too. Strange. Okay, so maybe I can't go into details here because of the bad communication. But that's what I'm doing. I'm just decided to bring it back to engineering basics to make sure the data looks right before you try to drive with it. And then wondering, why isn't it driving properly? So
Your audio is good now, Mike, now that you're on the phone.
okay, good. Yeah. So basically, on the can you see the Foxglove also?
Yeah.
Okay. Yeah, so you can see that when my forward velocity starts, my angular velocity, the blue line, goes down, which is the wheel's calculation of what it thinks the angular velocity should be, and then a half a second later, the IMU reports it. So,
Oops. Your shared just dropped.
wonder why it does that.
I think you.
I've been removed from the meeting.
You know, I wonder
Why
if it
am I
has something to
removed?
do with the vehicle doesn't start turning until it starts moving forward a little bit.
Yeah.
Yeah, it could be. I mean, it's a big vehicle with a real sloppy suspension. Yeah, so I'm thinking maybe that's what's going on. Yeah, it's trying to get back in the meeting.
Is there a lag between like the joystick input and actual seeing the wheels move?
That's a good idea.
Like if you push the wheels hard left, does it seem to take a half a second to start doing anything maybe?
It doesn't seem like it's a half a second. It seems like it's 100 milliseconds or quarter. Yeah, but it's not a half a
Pretty
second.
quick, yeah.
I just looked at it to see what's going on. Okay, I'm trying to reconnect the computer back into the meeting. It doesn't.
I think your computer is still connected because we've still got your video.
Oh, that's a cell phone, isn't it?
Yeah, I don't see his computer.
Yeah, me neither.
Oh, okay.
Threw up its hands and said, I can't do it. It's too much.
Now he lost the phone. Oh, he's back. No audio.
You're muted, Mike.
Well, yeah,
Still
he's
muted.
muted on the web interface because
Okay. Yeah, because when I logged in on the computer, it logged me off on the phone, so I had to relog on the phone, and it muted me when I logged back in. So.
You're muted again, Mike.
So, what am I doing here? Yeah, Mike, it's all messed up with all this multi stuff. So I'm going to stop my presentation. So because everything is just not working well. the technology is just not doing well. So I'm gonna stop trying to be fancy. I'm gonna turn my phone off.
It is an interesting question.
Yeah, I kind of wondered about that. I mean, I use the B&O 055 and it seems to work really good as a compass. But Kareem was saying, don't do that. Use
Okay.
your GPS unit to give you an angle, yaw angle. And I wondered if anybody else does that. I hadn't heard that they did, but.
Well, I find the gyro a lot more reliable, at least short term, than the actual compass. The compass will drift 5-10 degrees back and forth. But the problem with the gyro, of course, is it drifts over a few minutes.
Okay, I'm done. I'm done.
Okay, but if I don't know, you've got, well, let's see, you're using a lot more than the magnetometer in B&O 055, or you can use a lot more than just the magnetometer. And so I don't know. I have one platform where I calibrate it once, I get all threes, it stays all threes, and it works, I think, really good. It was an actual lawnmower that, I could tell it to move like, so many meters forward, do a 180, so many meters back, and it would keep going back and forth.
Yeah, the problem I've had with is getting the magnetometers to calibrate also. Sometimes they'll take, I have to spin it around a few times and it'll take a minute or two and then it'll go out of calibration and it'll lose itself. And so.
Yeah, I noticed that if I stop for a few minutes, then the calibration slowly goes to 0.
Yeah.
But I figured once I'm going on a course doing the thing, it's not going to be stopping for a few minutes. It'll keep moving. So I'm thinking it should maintain the calibration. And then as soon as I start moving again, the calibration will come back. It might go off in the wrong direction for a little bit, but then it'll go correctly in the right direction. And I think I can get the GPS to help in direction too, once it gets moving. I'm hoping that the EFK filter, when I give it the GPS stuff, that it can understands velocity or orientation. I got to study that, but.
Yeah, Mike, you could have it going in circles or some complex maneuver just to keep the calibration up, and then when you're ready to go, you don't have to
I had this annoying problem where I didn't realize it was going out of calibration, but I'd have it sitting waiting to do a run while I fiddled with stuff, and it would go out of calibration, so it would start off in the wrong direction and go for like 30 seconds and then then it would recalibrate and it would turn 90 degrees back to the right direction. But yeah, it took me weeks to figure out what was going on with that.
Yeah, so I figured I'd do the calibration dance right before I'm supposed to start, like within a minute. It's like, okay, I'm in place, I'll do a calibration dance and then start. Immediately after the calibration hits 3. So maybe my initial thing is like start the course and do a calibration dance. Then once it gets calibration status of 3, and I'll say, okay, now start the course. So I'm thinking that might be my procedure.
One of the calibration videos that I saw, I don't know if it's adequate. That's what I try to do. They say, just like for, what would that be? Roll. Yeah, I think that's roll. Yeah. Anyway, so like for roll, set it flat, move it up to like a 45-degree angle, hold it there, move it flat again, hold it 45 degrees, hold it flat again, and it should calibrate. And you can do that for all 3 roll, pitch, and yaw. What, as far as what you were doing, what were you trying to, let's see, how'd that work? I guess if you're doing yaw, that could be like 45 degrees to the left, 45 degrees to the right, maybe. I think that.
Yeah, I would have it go one direction and then back up in the other direction, then another direction, and just do a little clover leaf for,
Oh,
Yeah, I think
Yeah.
for
Like a
the
whole
magnetometers, it's best to go 360 so you cover the whole range.
Yeah, so I was thinking I'd do a clover leaf, go forward, then change the wheels and go backwards and forwards and backwards, and it would cause it to go in a circle, but not take a large space. It could stay in a
Mhm.
tight.
Yeah, I think
Yeah.
that's
Yeah.
right. Yeah.
hmm.
And
So you
I've
think
been
doing
doing
the-
that with
like the
with
full-
my remote, and it seems to work. So I just need to code that up.
Yeah. So Ted, you were saying it would be better to actually go 360, not just like plus or minus 45.
Yeah, because it's a magnetometer, so it needs to know like all the angles around, right?
Mm-hmm.
Yeah.
Yeah.
And Mike's doing that. He's not driving a circle, but it's the same result.
Same sort of thing. Yeah. Covering all the angles.
Yeah.
Right. And it does a lot of jerking, and that's good for calibration. Yeah. It likes to be jerked when it's calibrating. So hopefully I can get that dance working. And I was thinking that little cloverleaf dance, it'll point the camera in different directions. So when I'm close to a cone, say, hey, there's a cone somewhere here, then I'll do a slow motion version of that to scan the field without moving over a big area.
You just recalibrate,
Yeah.
It keeps it calibrated, but it's looking for looking for the cones. Yeah, so I have to do it slowly because you don't want to move the camera too fast. The AI, you probably just want to make it do a slow movement. So
yeah.
I was thinking maybe that should be a circle, but because that's a relatively slow. But
Yeah, even with blob detection, if you whip around too fast, it won't recognize the blobs, it seems.
Yeah, so I might have to go and then stop and then back up and go and stop, back up and go and stop, to make sure that I have a 45-degree angle field of vision for each stop. So in the 45-degree field of views will overlap, so I get the whole 360 field of view when I go in when I'm doing that dance, the cloverleaf type dance. Yeah. So that's sort of my plan.
Sure would be nice if you could manage somehow to put encoders on those two rear wheels so you could get better real odometry versus steering setting.
Well, the two wheels are linked with a differential, so they're sort of basically running at the same speed and just slipping, I think.
Has anyone used optical flow sensors for things like this?
No, I think Kareem's probably experimented with those the most, maybe.
I
But no.
experimented a little
Outside,
bit.
that
but
probably wouldn't work well, but yeah.
yeah, I had a lot of troubles getting it to stay. I think it was just moving faster than my optical flow was capable of. I had one that was, I don't remember, I got it years ago. It was designed around an optical mouse kit that someone put out.
Oh,
Yeah.
God, what's that?
A few years back, it was Murray out of New Zealand.
Right.
Did some
Yeah.
outdoor and indoor calibration on different surfaces with the Pimoroni optical flow.
Right.
That's right.
So we have that in the YouTube somewhere in DPRG clips.
Yeah.
That must
So-
have been around 2022, probably 2021.
Yeah, my car platform did not have any encoders, and so I looked at it and tried to figure out where could I put an encoder on here, and the only place I could figure out where to put an encoder is on the drive shaft, and so I used a Go Build a Pod wheel and pressed it against the drive shaft, and that's how I'm getting the speed of the drive shaft, and so that gives me the speed of the wheels.
You know, there's a guy on another forum who's got a 1/10 scale truck that somehow has rigged up an like external wheel encoder on the outside. So he's got a off-road truck like you've got, and I'll send him a note and copy you and ask him how he did that.
Well, John, Jon, he's on here every so often. He did that on his 10th scale model, and on the motor he actually had a shaft coming out of the motor that was spinning, and I don't have any access to anything like that on my RV, so I couldn't do it myself.
Yeah, but that's not individual wheel odometry. And this guy I'm talking about did individual wheel odometry with some kind of outrigger. I don't remember how he did it though. I'll ask him and copy you on that email.
Maybe next year. It's not going to happen this year. But
you're right. Too late for that now.
But my shaft encoder works amazingly well. I'm really happy with it. I guess.
Was it using like an AS5601? It's the sensor that, it's got like 4,096 steps with a magnet that has kind of an odd polarization. It's not on the big surfaces, or rather the poles don't come out of the big surfaces. They come out of the thin part. And so you have kind of a north-south right in the middle.
Ray, I have this encoder. This is the magnetic encoder, this disc. It's a Dagu robot. And there's I think it's a Hall effect sensor that comes with it.
Oh, okay.
And
so that's probably more like the little Polulu, these things, right? It's got quadrature detectors on it, and there's a little magnet with, I don't know, like 22 north and south poles on it or something.
Probably. I think that, this is something like that. And
okay.
If you can fit the ring around your drive shaft, then that'll work also. You'll have to make something to mount it, but.
Yeah.
Yeah, and Pat has something there.
Right. Yeah, that's
I got one of those, but I
think it's based on the same chip.
Yeah.
As the 5601 or a copy there, of it or something. So.
Yeah, so on my big scale model, the drive shafts are about, the thickness of your thumb, like a half-inch diameter drive shafts.
Damn.
So at least had a surface area for that pod, the wheel odometry to go against it and get a good traction.
They're magnet. Yeah, the magnets can be really small.
Yeah.
Like maybe. Yeah. Not even a centimeter across or so.
Right.
That's about 5 millimeters.
Yeah. Yep.
And the magnetic poles aren't across the face. They're across the edge.
Yeah, the edge of it. Yeah.
Oh, interesting.
And it senses that line between the north and the south pole, I guess. It's as it rotates.
Yeah. Yeah, I was thinking of putting something like that on my servo to get a feedback on my servo, but then I realized that the linkage it has some slop in it, and then the tires themselves, they just move. They're really soft. They're not hard wheels or anything. So I
Yeah.
figured there's just no feedback I can get. So I have to use the IMU to feedback on the rotation.
Well, that's
So-
interesting.
so-
And it sort of raises a follow-on question of how could you possibly handle a rotation reading that was delayed by a half a second or advanced by a half a second from actual vehicle movement?
I guess you can't go at 10 meters per second. You can't travel very fast, that's for sure.
Yeah, typically in control systems, if you have a delay, that can cause instability. You know,
Right.
you can get oscillations and
Yeah, so I figured it'll go, go in the right direction. But once I find a cone, then I use visual odometry, and I use my time of flight sensors, and it gets really smooth once I lock onto a cone using my other sensors. I just have to get close to it and see it with my camera, and then get close enough to use my time of flight sensors, and then I can pull in really nice.
Have you run your truck outdoors yet, Mike?
Yeah, I have. And I just went for it. I said, okay, here's GPS, here's this and that. Okay, go 20 meters over there, and it just went all over the place. So I said, something's wrong. That's why I came back indoors
Okay.
to check out my sensors. I went for broken. It was broken. Yeah.
Well, gold star for Mike for showing his robot moving.
Yeah. So hopefully next week I'll have it calibrated. Maybe I'll get I'll turn the GPS back online and get it outside and see if it actually goes in the basic direction I want it to go. So.
That's exciting.
Oh, but I'm going to be out of town for 4 or 5 days over the weekends, so I won't be able to make it to the party at the Dallas Makerspace. But
Okay.
so I don't think I might not even be in back for Tuesday's meeting. So I'm running out of time. Yeah.
Okay. Well, that was an interesting discussion. Very puzzling. Where do we throw it open for open mic? Anything anyone has?
yeah.
Let's see. What have I come across lately?
Yeah, is anybody gonna jump in the queue?
Nope, you're it.
Okay, I'm in. Anyway, I was gonna try to dust off one of the Lidar lights. I don't know if people remember those or not. It was before Garmin bought them out. Anyway, apparently there was version 1 was a silver label. So there's the silver label on version 1. Version 2 was a blue label, and I had that on the servo and had it on my 6-can robot, and it actually worked pretty good. They're supposed to have like a 40-meter range outside, which is pretty good. And I had also had, this is one of the early Benewakis on the 6-can robot. And this didn't work nearly as well as, this is LED, the other two are laser. And it didn't work as well as the Lidar lights. So before Scott built the new course, if the course wasn't sitting on level ground in the corner, there was a gap, and it would always see that gap when it scanned across it and think it was part of the goal, because I was looking for a big change in distance as though the laser beam was shining through the goal, and it would screw me up a lot if that, depending on where the course sat, because then it would take the that first, where the two boards didn't line up, and then the other side of the goal, and try to pick an angle in the middle, which is just about the one side of the right side of the goals, say, and it would run into it. So, but anyway, so I was thinking of sticking this on the outdoor robot and trying to use it for distance, distance measurement and optical avoidance, and it's certainly not a God. What is the LiDAR that you have on yours, Paul?
I don't have a LiDAR on. I don't have a LiDAR on. Didn't have a LiDAR on Mobot when I competed last year.
Oh, you didn't? Okay.
No.
Oh, I thought you did. Okay. Anyway, on your latest platforms.
Yeah, the latest ones, those little baby mini-bot and the Maker's Pet have LiDAR, but that's used for, they're indoor robots, and it's used for localization within a map.
Mm-hmm. Yeah, and Mike is using one outdoors, so Mike Williamson, right?
Yeah.
Yeah.
I'm using. Yeah.
Oh, the S3.
Yeah.
Is that specifically made for, like sunlight conditions, or?
It's optimized. Yeah, it has better sunlight performance.
Yeah. Whereas the one that Paul has, is yours going to work outside or too bright for outside use?
I don't know. I mean, it's only for an indoor robot, and I don't figure on using LiDAR for localization outdoors, because I don't think I have a map. And if I'm outdoors, GPS is a way better thing to use.
So, I was going to use my LiDAR outdoors as obstacles. Well, basically, when it tries to map a path, because there's no map, it'll say, well, there's something there, so I can't go that direction. So it'll.
Right. Yeah. That's what I was going to do too. So I don't know if I'll incorporate it in time, but anyway, these are so old now that, it's like you have to really search around for code that used to work for these. They're only, they're like less than 10 years old, but there's a version 3 now, a version 3 HP, which is high power. And it's not LiDAR LED anymore. It's owned by Garmin. So,
So are you bringing your robot to Robo Columbus, Ray?
Yeah.
Excellent.
Gonna try to.
So for your time of flight sensor, it's not 12 volts, it's 5 volts, right?
What's that?
Your time of flight sensor you were showing, it's not 12 volts, it runs off of 5 volts.
Oh yeah, these are, well, at least I think you can run it on 5 or 3.3.
Oh, okay. They're not that old then. Yeah.
Yeah. So
Right.
yeah, nope, not that old. So
Right. Have you looked into the Garmin version of that and seen how well it is?
no. These were back in the day. I think I have a receipt here. It was like $89 for one of them, and I thought the Garmin really jacked the price up quite a bit.
Oh.
I haven't looked at one recently, but I remember it just seemed like once Garmin took it over, the price might have doubled or something.
Yeah, I think it's around, it was 150 last time I looked at it a few years ago, so it's probably even more now.
Yeah, this is 89.95.
The Garmin's they're similar as far as the capabilities, they're close. It's about the same thing. They didn't change much, is what I'm saying.
Mm.
And the TF minis don't work very well at 3.3 volts. I think you can get them to work, but they have problems.
Oh, okay. Yeah. When I had it on my 6-can robot, it was, hooked to an Arduino Mega, so it was running on 5 volts. But,
Yeah. Yeah, you kind of want them on 5 volts is what I found.
and this, I think indoors, this might be good for like 8 meters. Outdoors, I don't know. It's
Not much.
somewhat
And
less.
also, if you've checked, the price of those have gone up a lot. I was looking at the other day, it was like $70 at SparkFun. They used to be 30, I think.
Yeah, quite a
Yeah.
bit less. Yeah. So
My sensors have gone up too. I'm sure glad I bought them last year.
Yeah.
yeah, so we'll see how that goes. My bumper scheme didn't work that well last time, so I just had a bumper with 2 switches on it, and I was using that for sensing, hitting the cone and for other obstacles, but didn't work that well at all. So
My RP Lidar worked pretty well outside. It could see 20, 30 meters.
Wow.
You could see the fence lines, far, far, far away.
wow.
And my ST micro time of flight sensors, my 8x8 sensors, they seem to work pretty good
Outside, yeah.
Yeah, I haven't stressed them like, okay, point them at the sun and still see and see if, when the sun is setting and you point in that direction.
Yeah.
Maybe not.
Well, I was thinking about that. We usually have the contests like midday, so
Right,
sun
right.
directly down. Well, okay, not where we are, but
Yeah.
not
But it's not on the horizon. Yeah.
not on the horizon. Yeah, so but definitely lower in the winter sky. So anyway, that was all I had. That's what I'm going to try to do, resurrect some code. And I had tested the, I think the Lidar Lite version 1, and trying to remember how far away that is. Somewhere between 15 and 20 meters away, I could see, a scan of a brick wall on a house. And so, you wouldn't think bricks would be that good as far as reflection or, the ability to reflect a laser light beam, but it seemed to work pretty good. So, so hopefully it'll work as well for obstacle detection. So if I can sense it far enough back to say, okay, I'm going to have to change course here. So,
Yeah. I was testing my GPS outside, and I realized as long as I stay away from buildings, because the houses here are like 20, 30 feet tall. And if I get too close to a building, then it's not good.
yeah, you get reflections
There's reflections or something. And then the satellite in view have to be like 5 or 6 minimum, preferably much more. And when I did that, then I got like 5 by 5 meter resolution. I'm going to answer this call.
Yeah, I thought there was something. There's a tree that's common in Texas. I don't know if it might be a live oak. It's the distance like stem to tip is close to a quarter wavelength of some of the GPS signals that are used, and so it's like if you got into that tree, it was like this array of little antennas that
Like a Faraday cage.
But yeah, kind of, yeah. So
You were trying to get a RTK GPS system working last year. Do you think you got a handle on that thing now, Ray?
I I can get the base station to, go in survey mode, and it completes it. And with uBlox's, I don't know if that's their GUI or whatever, their tool, I can actually see have it interpret the UBX correction. So I can actually see that coming across, and it looks good. I never saw the rover change into fixer float. So it looks like it's receiving the correction data, but it used to, I at least got it into fix before. So I don't know if I changed the code and broke it, or
are you using somebody's package for running the UBX receivers, or is it your own code?
No, it's just what SparkFun had.
Oh, and it supposedly works with RTK.
Yeah. Yep. Yeah. And these are the 8-2s. They're not the 9s. So they're, as far as the accuracy goes, the 9s are more accurate than the 8s. And
right. They don't really do RTK GPS. They do differential GPS.
It was actually supposed to do RTK. I think the resolution wasn't as good. I think you could get it down to like 2 centimeters, not 1. As far as, I can't remember which accuracy that was, the horizontal accuracy, I think. But yeah, supposedly with the H, you could do GPS RTK. But so I have to look into that too, try to figure out why it doesn't seem to be going into it.
Huh. M8P or M8S?
I thought I'd have to look it up.
Okay.
Oh, well, I have one right over here. It's a Neo M8P-2.
Yes, this does RTK.
Yeah, it says it's supposed to do it.
Huh.
There was it looked like somebody else really got into the internal registers of the part and figured that the stuff that SparkFun was providing hadn't set all the registers that it needed to set to accept the correction data, and I hadn't tried making those corrections, but
Okay.
I thought the stuff from SparkFun would have worked. And like I said, I think they made some revisions of the code over time, and I'm not certain which one I've used, and so they may have dropped something that they need, should have been in there. But it seems like their focus was when the 9 came out.
Okay.
They seemed to focus on that quite a bit. And I don't even know if you can buy those parts from SparkFun anymore. I haven't looked in a while. The 8s. I think you can still get the 9s, but anyway.
I've got something I can share that might be of interest to some folks. So are you seeing this, my little robot with the electronics?
Mm-hmm.
So this is something I whipped up over a few days ago to charge 2S Lipo batteries off of a USB-C, and So this is there's a USB, there's a 2S BMC here, battery management controller, that's wired up to the battery. So there's two 18650 batteries in the battery holder. That's the black box that these circuit boards are sitting on. And so it's wired to B plus B, B minus, and BM is the middle tap of the battery. And then P plus and P minus goes off to the electronics, where it provides 7 to 8 volts depending on the charge, and also off to this little USB to 2S charger. And all it is, it just takes USB-C 5 volts off of USB-C and pumps it up to 8.4 volts, and then that gets applied to the P plus and P minus terminals of the BMC, which will cause charge to flow into the batteries until such time as the batteries are full. So here's a circuit diagram of it. So it's real simple, but nothing fancy, but it's a simple and inexpensive way to handle charging 2S Lipo batteries off of USB and providing under voltage, over voltage, over current protection, and allowing you to plug and unplug your power source so you can run the robot off of AC power while it's sitting on your desk, but then unplug it and everything stays alive because the battery switches over to the battery starts providing power once you unplug the USB, and then run the robot around the room.
Mm-hmm. Yeah, that's kind of neat. How was the 2S battery, I guess, monitor charger part? Was that pretty cheap?
Yeah, it was real cheap. The charger part was, I think, $10 for two, and I think the BMC was maybe 15 for two, something like that. So they're both really inexpensive parts. And the BMC is rated at 15 amps, so it's got like plenty of capacity for a small robot.
For two little 18650 batteries, right?
Yeah.
Yeah.
And the battery charger is rated at 2 amps at 5 volts, which would translate to probably 1.4, 1.5 amps at 8.4 volts. So it's an appropriate charge rate for some 18650 batteries.
Yep.
So anyway, that's all I had. It was
pretty good. Yes, some of the ESP32s that you can connect the battery to have built-in charging. So that's as far as keeping your supply rails quiet, a battery is a pretty good choice versus switchers can add a lot of noise to it. So, but it's kind of a nice thing to plug it into USB and it charges the battery, and same sort of thing. If you just unplug it and it'll run off the battery. And
right. The thing about the ESP32 boards though is the batteries that they're designed to use will be like 1S.
Right.
1S 3.7 volts, and not suitable for driving robot motors.
Oh, that's true. Yeah.
And this BMC has got balancing. So it's a reasonable solution. I was quite happy when it worked.
To have it on board.
That was all I had. Anything else? If not, is it time to call it a night?
Here, actually, I have one question. So,
What's that, Jason?
I do have one question. So I have the EKF filter, the extended common filter working. So now I need to go to the waypoints, right? Is there a package or library that you all are using, or are you also using GPS to correct the drift? And is there like another package I should add on top of that?
What's your environment? Are you running ROS or something?
I'm running a ROS 2 Humble.
Oh, so there I to go to a waypoint.
I'm not
So
certain what
maybe-
this question was.
So the question is, Jason's got his EKF filter running now. How does he do navigation between waypoints?
Like, is there a package I should be using, or should I just write it from scratch? That's kind of what I'm asking. Because I know they have like pre-made packages for the waypoints, but that seems like, you know, a lot of debugging that I'm not sure if I really want to do. But
Yeah.
but yeah, I don't know. I was wondering what was common practice or what the different methods were there.
So I think Mike and I were the only ones running ROS robot last year, and I know that if you implement nav2, it can do waypoint navigation, but it may be a simpler approach if you want to fork my repo. I've got a repo called Scriptbot driver that accepts script commands. Well, why don't I just show you what it is, and then you can decide whether you like it or not.
Yeah, that'd be great. Are you going to send that in the chat, or are you going to be in the Discord?
I can put it in the chat, and I can just give you the overview of what it looks, like what it is. Let me bot driver. And let's see, let me put it in the chat. How can we get to the chat? Just have to go back to here and paste it in the chat.
Yeah, I was going to say, if you're, I guess if you're using ROS, I don't know if you can incorporate what David Anderson did. He had a, method basically to calculate what your
So I
meters to
actually
go and the
cloned-
angle to
I
drive.
cloned David's, not his code, I think, but his algorithms.
Mhm.
I may have cloned his code. I just don't remember.
Yeah.
Oh, it's pasted in multiple times. Sorry about that. My let me try. Let me see it one more time. There we go. There you go. Okay, so scripted bot driver, set of nodes that outputs motion commands and monitors odometry to cause the robot to move according to provided commands and parameters. The robot should accept commands from twist messages like command val, which is standard ROS, and it should provide pose feedback in an odometry message. And And so here's how you launch it. Now, where does GPS fit in? So I fitted. I don't. Do you have GPS, Jason?
Repeat one more time.
Do you have GPS?
Yeah, we have GPS. Probably gonna get an RTK at some point, but yeah, we have a GPS. I was just wondering because the EKF filter, it was correcting for wheel slip from the IMU. So I was wondering, am I supposed to do another layer of sensor fusion by incorporating the GPS? Yeah, that's my question.
Yes, because GPS gives you your position in the map frame, whereas odometry gives you your position in the odom frame.
Okay, I wasn't sure if there was like a package I was supposed to use because EKF node, DKF node, it took an IMU. I just didn't see anything in there about GPS. So I wasn't sure if that was in the level I had to implement or. Yeah, I mean, so I see a lot of pre-made solutions on GitHub, but I mean, without having to dig through everyone's code to see they did it would be great.
Yeah. So drive waypoints is a command that you can give to a script that this package will consume and give it a target X, target Y, and a whole string of targets, and those are really the waypoints that it'll drive. And so here's an example of running it. Scripted mover. Movo means move odometry straight 3.2 meters, stop for 2 seconds, then move odometry minus 3.2 meters. And that stopping, so from a Robo Columbus strategy standpoint, you really want to drive to within 10 feet of the cone, then stop for 2 seconds, then advance to the cone and try to touch it. And the reason is because you get 1 point for arriving within 10 feet of the cone, another point if you stop within 10 feet of the cone, and then a third point if you actually touch the cone and don't move it enough to knock the ball off. So you really want you want to get that second point in case you miss the cone, so that at least you'll get 2 points out of arriving there instead of 1.
Okay. Yeah.
Paul, when you're touching the cone, like if you're within a centimeter, is that touching it, or you have to actually physically touch it?
You have to actually physically touch it.
Okay.
Isn't there like extra points to knock it down or something? I feel like I vaguely heard that in the video. Or is that a joke?
You don't get the third point if I remember correctly. If I remember the rules are on DPRG.org under competitions. But if I remember right, you don't get the third point if you move the cone enough that the tennis ball falls off the top.
Okay, understood.
And then here's an example of the scripted mover drive waypoints command with a number of pairs of waypoints to use. And you can run it, you can test it on Turtle Sim. So that's, like, let's get a feel for it. And this uses ROS actions to drive. So it has a base class that runs most of the actions, and then subclasses that run the drive straight, rotate by odometry, drive waypoints, and so forth. So that's one approach, and I'd be happy to walk you through that and explain more about how it works.
I'll probably go through it on my free time. It's kind of getting already a little late. But yeah, I'll reach out if I have any questions. But now I'm at the point where the video works, the GPS works, the drivers, the motor drivers work. So now I just need to put everything together. And some of the filtering is already done. So I need to do the actual the actual program. Yeah.
Yeah. And I was looking, but I couldn't, for some reason, locate the actual code that dealt with fusing GPS and odometry. I know I took a shortcut there, but I just don't remember what I did. I think if I remember right, I might have just used GPS and thrown away the odometry, because if you got RTK GPS, you don't really need odometry.
Right.
So I might have. I'll have to remember, and if you ping me an email, I'll go find where that code is. And but I think I might have just taken the XY coordinates out of GPS and computed the heading based on the last couple of GPS coordinates that I received, and stuffed that in an odometry message. And then I know I used scripted bot driver to do the waypoint following. So I had, for running the whole course, I had a big long script string that I assembled and tweaked on the day of the competition with the actual positions. But it went something like drive waypoints, and then a number of pairs of intermediate port waypoints that steered it around the rough points in the course and gave it a sort of smoothish kind of path to the vicinity of the cone, and then a stop command like stop to, and then I had a seek to cone action as well that would drive slowly forwards towards a waypoint, but abandon the motion when it detected the bumper push. And then I'd have a stop command there, and then a move O backwards to move backwards like a meter, and then drive waypoints off to a string of waypoints off to the next cone. So just strung the whole thing together in one big old script, and it just executed each piece of it one at a time.
Okay. Thank you. I'll read through the GitHub and see what I can do. Thank you.
Any other comments or thoughts on that?
Yeah, well, I'm going to be scripting mine using a YAML file. Yeah. So as the format of the file, so it'll basically say, here's waypoint 1 coordinates. And basically I'm expecting each waypoint to be a cone, but maybe I should do what you're doing and add some intermediate ones if I need to. But I want to try to do it without intermediate waypoints. I just want to say, go to where the cone is. It's just regular GPS, so it's going to be really sloppy.
Thank you.
But you kind of have to have some waypoints between the cones where you can't see the next cone from the cone you're currently at.
Yeah, but my Lidar is going to see there's something in the way, and the navigation software should map around that. Should say, hey, there's something there, but here.
Is it going to
I'm guessing that's what.
Is it going to turn left or right at the weeds? Because if it turns left, it'll go in the lake.
Yeah, that's what I'm worried about. Is the lake is like a really nice open space. Yeah.
You better figure that one out, Mike.
It'll hit the fence, I guess.
Maybe foam-filled tires that add enough buoyancy to.
Oh, it can swim over to the next cone.
There you go. Just jump in the lake and.
Yeah, because there's a sort of an arc, right, where you come from out of the first cone, out of the cove, where, if you will, where the first cone is, and then you got to go around these trees and weeds, and then along and past a couple of hay bales, and then kind of turn left and go towards where the second cone is. And then when you go from the second cone to the third cone, there's like, again, you got to arc around the house. So is it going to turn left or right when it sees the house? And you got those sewer pipes that are sort of sticking out in
Aerobic
there.
septic system, yeah.
Yeah.
Covers.
Yeah.
I thought, correct me if I'm wrong, but I thought if you just used the 3 waypoints and had good enough obstacle avoidance, you got a higher score. It was, deemed a more difficult method of doing it. So I thought, but if you did pick intermediate waypoints, that was deemed, easier. And
I don't think I know what you're referring to, Ray, and I don't think that's you're quite. I don't think you're quite right there.
I believe if you don't use intermediates, you get 1 extra point. Yeah.
is that what it is? Yeah.
No. I don't think that's right. Hold on, but let's go to the rules.
Where is the rule meister? He's not here tonight.
The rule meister's not here, but we have the rules. Here they are. Okay, so you're talking about how you earn extra points.
Yeah, or just that you were given extra points if you just use the 3 waypoints versus intermediate waypoints. It's too small.
Nope.
I can't see it.
Oh, that's the remote. That's the wrong one. Robo Columbus Plus.
Can you zoom in some?
Yeah. Is that good?
Yeah, 1 more. Yeah.
God, these are extensive rules. Come.
Additional challenges. That's what you're referring to. Okay. If you score 9 points, so this is, you can get 9 points without, even if you follow waypoints to avoid all the, like go skirt the weeds and avoid the hay bales and all that stuff. It's rewarded with an additional point if it gets 9 and does not use any form of GPS or RTK GPS. So, okay, there's, and that wouldn't apply to you. So that's not
Right.
the point you're talking about. Or if it scores 9 points and uses 0 waypoints.
And you only get 1 point for that. That's crazy. That's really hard.
Well, but
Yeah, I don't think anybody did that. Okay. So the maximum score for a robot run is 11.
With no waypoints.
the 3
Oh, that's the
waypoint
no
challenge is
waypoint.
mutually
Okay.
exclusive from the 0 waypoint challenge.
Yeah.
Oh, so if you use 3 waypoints, you get an extra point. Yeah.
Now let's just read this and get the exact
Okay. So
definition
that would
of
be
what
10.
0 waypoints means. We might need the robot, the contest master to clarify this.
Well, okay. The way I read it is, if you do everything, you can get 9 points. With extra waypoints and everything. But if you don't use extra waypoints and you only have 3 waypoints, which is 1 for each cone, it's rewarded 1 point.
Yeah. So you get 10 points then.
Yeah.
Right.
Right. So
Yeah.
that's all built into that first dot there. And then if you don't use GPS, you get a point, but you don't get any extra point because of no way. Yeah. So, yeah.
Okay. Yeah. Okay. Yeah. So that's basically, if you're using it in intermediate points, you can only get 9.
Yeah. And if you don't use it, you get 1 point.
Right. You get 10 if you make them all. Yeah.
Y'all are on the DPRG email, right? DPRG list.
Should be.
So let me clarify that with Doug, because I had a different understanding. So I want to get the ruling on this. And so Ray and Mike, your understanding is that 0 waypoints means no waypoints between
Well,
the
three
cones.
cones. If you have three
Yeah.
waypoints, you got one waypoint for each cone.
Yeah. And
If
that's
you have
it.
extra waypoints, then you don't get the extra point.
Mhm.
Yeah.
Yeah.
Okay.
But if you don't use any waypoints, then everything's visual or something. You just have to run
Yeah.
without.
Using a white stick to try to find the cones.
Right.
But-
And then
But
you
that's
get
not
1
the
point.
0 way. Is that the 0 waypoints challenge that you're talking about? Is where you don't even have the waypoints for the cones?
Right. That's what I thought it was. Yeah.
Yes.
Yeah.
So you have no waypoints. If you have 3 waypoints, that's 1 for each cone, and you get 1 more point. You get an extra point relative to if you have multiple waypoints between cones.
Right. Yeah. So how did you set your extra waypoints? Did you just look at Google Maps and say right about here is good, or?
No, I walked the course with the electronics out of the
Oh
robot
yeah. Yeah.
and noted where I wanted the waypoints to be.
You carried the brains around and left
Yeah.
the body behind.
Right. Because you're not allowed to take the robot on the course, but you are allowed to take the GPS receiver and the electronic.
So we found
Yeah.
a loophole. Yeah.
Yep. Yeah, I'm with Mike. I think that's how you interpret it, but you have to consult Doug on that to get the official. But yeah, because it is a little bit more difficult. You know, you really have to have good obstacle avoidance because it's not line of sight to the next 2 cones. So the second and the third cone.
And somehow you have to avoid the lake. That's the tough part.
Avoiding the lake is good. Yep.
Okay.
Yeah, 2 years ago the cone was pretty close to the water. I mean, within
It was
5 feet or something.
10 feet, 5 feet. Yeah.
Something like that. Pretty close, yeah. Or you're stuck in the marshy area.
So I see. So you have to declare. You have to declare at the outset that it's whether you're competing with 0 waypoints or
more than 3, I guess.
or 3 or more. Is it?
Yeah.
Yeah.
So 0 waypoints, 3 waypoints, or more than 3.
Yeah.
Gives you different levels.
Mm-hmm.
I don't think anyone's going to do the 0 one. So.
Yeah. Yeah, have GPS at least, maybe not RTK, but good enough,
What's the robot planned category?
Yeah. So I'm thinking that this year I'm going to use just plain GPS. I'm going to get so disgusted that next year I'll have RTK.
Yeah, but if you have pretty good blob detection, bracket as many as you can, and you should be able to find it. Or if you're going to use a model, I kind of wonder. I'm almost tempted to set up 2 cameras, one with blob detection and one with with a model, and see, okay, which one does better, side by side.
Yeah, my cone detector is pretty good. I'm using the online one, the Cone Slayer, that I just downloaded. And I'm using the primitive model of it. I figured if I have to, I can do the more advanced model, but I want to use the primitive one because it's going to take more GPU power to use more advanced. Like the primitive one has 3,000 connections, and then the more other one has like 30,000.
Okay.
Lots more.
I believe you guys' interpretation now. Now I've read this. I believe you're correct.
Yep.
You have to declare at the outset it's either using more than 3, which is human planned, or robot planned, which is only 3,
Mhm.
or 0.
Which is just crazy to start. You know,
Yeah.
I don't think we've gotten any takers on that challenge. It's kind of like, yeah.
All right. All right. I think we're on the same page now. All right. Anything else?
So Paul, you have a new challenge now because, you know, you've used more than 3 waypoints, right?
Yep. Well, you know, you need a good robot like Mike's that isn't going to be bothered by things like sewer pipes sticking up in the out of the ground.
Yeah, but the lake will still get me. So
Yeah, you better. Well, you know, you don't have to. You could still build in some knowledge about how you expect the course to be without actually using waypoints. You know, you could say, I know I need to go south from the first cone for like 10 meters maybe, and
yeah.
I don't know. Maybe that's violating the spirit of. I don't know. That's something for the contest master to rule on.
Yeah. Well, he was saying this year is going to be a different layout. So yeah.
Oh.
Yeah.
Yeah, I guess it's been different. Well, I think it's been different every time. There's even like subtle changes, but yeah, I actually bent it's the output shaft of one of the Go Builder motors, and grabbing the robot, trying to keep it from going into the weeds. Actually bent one of these shafts.
Whoa.
So that's a replacement shaft for it. Haven't put it in yet, but
Wow.
yeah. Don't grab your robot.
All right, gentlemen. Shall we call it a night?
Sure.
All right. Good seeing you all. See you all next Tuesday.
Or Saturday.
Paul, you want to stay on for a sec after?
Yeah, that'd be great, Pat. Thank you.
I just thought rather than email back and forth, we can just discuss.
Sure. So
doing
I'm
the video.
available. Let me think what I've got going on tomorrow. I gotta pick up the boat. I'm available tomorrow afternoon or Wednesday morning, or what works for you? Because you're a working dude. You need to drive the what's I'm
Yeah,
quite
I'm doing some programming tomorrow or whatever this week, but I can make time in my schedule. So you're saying like tomorrow afternoon? What time are you thinking about?
like maybe 1 o'clock Central.
Oh, yeah, that would work.
Okay.
I figured we could go through today's meeting. And
Yeah.
that would give
Oh,
us
that'd
real
be awesome. Yeah.
tools.
Yeah.
So
That's
you
great.
want to just meet on
On the same Google Meet, sure.
yeah, we can either meet on the meeting meet or link or the one we sent out the other day.
Yeah, we just did an ad hoc one that's only good for an hour. If we use this
Okay.
one, it's good for as long as we want. I hope it won't take an hour, but shouldn't.
Yeah, that's fine. Let's go. Let's just use this one. So 1 p.m. your time tomorrow.
Yep.
Okay.
I'll send you a meeting invitation,
Okay, great.
and it'll have the meeting link in it.
Perfect.
All right. Hey, thank you very much for offering to do that, Pat.
Well, I do what I can. I'm located far away, but if I can help out, I'll help out.
Appreciate that.
Do anything I can.
Thank you.
No problem. See you tomorrow.
Yeah, see you tomorrow.